Module 16 Test Review for Math 2. Problem number 1. They show us a grid with two triangles, and they're asking us to find the ratio of the corresponding side lengths. In class, you learned that when you do the ratios, it needs to be the image over the pre-image. So I marked the triangles. The pre-image is the one without the primes, and the image is the one with the primes. Start with the numbers that they gave me, 13 and 17. 13 is the pre-image, and it goes on the bottom of the fraction. I marked AC and A prime C prime in green with 12 and 15 after counting. 15 is the number that goes on top since it comes from the I, and 12 goes on the bottom of the fraction. I marked the sides BC and B prime C prime with 5 and 8 after counting. I don't know for sure that these fractions are equal to each other, so at this point I'm just writing them separately. In question number 2, they're asking me if this is a dilation of the pre-image. That means I have to check if the fractions are actually equal. If this was a dilation, then we would have a scale factor. Since my numbers are all different when I divide the fractions, I can see that this is not a dilation. And I have to give an explanation. So I said not a dilation because the sides are not proportional. Let's move to number 3. On number 3, they're telling you that J prime, K prime, L prime is the image of JKL, so a dilation occurred. What is the scale factor K of the dilation? So we know that JKL is the pre-image, so I put P, and J prime, K prime, L prime is the image, so I put I. We also know that if we're looking for a scale factor, then we're looking for I over P. So I need to create a fraction so that I can find my scale factor. I want to choose an I over P that would be helpful. Here it's not very helpful. Zeros are not helpful. The 2 divided by the fraction looks a little difficult. Another fraction divided by another fraction looks a little difficult. But here I have numbers. So I'm going to use those 2 numbers to help me find my scale factor. So I chose -6 and -2. I put -6 on top since it comes from the I, and -2 on the bottom. Once I reduce, I find out that K is actually equal to 3. So that means that this shape got bigger, 3 times bigger. And my answer is K equals 3. On problem number 4, they're asking us if our shape here is a dilation. So Kylie took a photo that measured 4 by 6, and supposedly she enlarged it to 6 by 9. But we're trying to find out if this is a dilation. It would help here if we draw a picture. So as you can see here, Kylie first had a picture that was 4 by 6, and supposedly she enlarged it to 6 by 9. But we need to find out if these sides are actually proportional. So I'm going to set up some fractions. My first fraction is going to be 4 over 6. My second fraction is going to be 6 over 9. And I'm going to check if these are actually equal. So I can do that by cross multiplying these two numbers. So 9 times 4 is 36. And 6 times 6 is also 36. So that checks out. Yes, our original shape is a dilation because the sides are proportional. And this time I'm going to use the symbol for proportional. Let's move to number 5. Problem number 5. A figure has a vertex of 4,6. The figure is dilated by a scale factor of 1/2. The resulting image is then dilated by a factor of 5. What are the coordinates of A double prime of the final image? So you're going to have to do 2 things. Number 1, we have a scale factor of 1/2. That's going to give us A prime. When we're done with that, we're going to have another scale factor of 5. So that's going to give us a double prime. So we're ready to get started. We're going to start with our A, which starts at 4, 6. And it says that we have a scale factor of 1/2. So you're going to have to divide everything by half. So that means A prime is going to end up at 2, 3 after we divide by 2. Then we have a scale factor of 5. So that means A double prime is going to be multiplying those two numbers. So A double prime is going to be 10 and 15. Okay, if you're confused, then we're going to divide here by 2, and that's how we end up with those numbers. When we're done with those numbers, we're going to multiply each one by 5, and that's how I ended up with those numbers. So our answer for this problem is A double prime is at 10, 15. For our next problem, they're asking us to use the graph to answer questions 11 through 13, and the graph is up above. Triangle ABC is dilated to create triangle A prime B prime C prime. This is our image, and this is our pre-image. And once I looked, this triangle is not on our paper. So let's move our way up to problems number 6. Because they're asking us to use this on questions 11 through 13. So we'll come back to this when we get to problems number 11 through 13. Okay, we're on number 6 here. Use the following information for 6 through 8. You have an isosceles triangle, FGH. And that is the pre-image. So this is our P before anything happens. And then we have a scale factor of 3/4. So we're going to have to do a dilation. So in order to do our dilation, we're going to have to find our coordinates. Once you get the coordinates, now you need to multiply each one by 3. And you need to divide each one by 4. It's easier if you line up your points and do everything all at once. So we're going to multiply by 3 on each one. So you will end up with 0, 24, 24, -12, -24, and -12. Then when you're done with that, we're going to divide everything by 4. And we will have the coordinates of F prime, G prime, and H prime. So here are the coordinates: 0, 12, 6, -3, -6, -3. And we're ready to graph so that we can see what shape it is. You can see that I'm graphing it in red. F prime, G prime, and H prime. And you could see that the shape is still a triangle. So that's the answer to question number 6. In question number 7, they're asking us the coordinates. We already gave those coordinates. So it's F prime is 0, 12. G prime is 6, -3. And H prime is -6, -3. Is the dilation an enlargement or a reduction? Since the scale factor is greater than 1, it was 3/4. Oh, excuse me, it was smaller than 1. Since the fraction is less than 1, then that means that this was a reduction in size. On problem number 9, they're giving you the coordinates of the image. which happens after. But we need to come back to the pre-image. So that means we need to reverse what we are doing. So if you look at the scale factor is 1/4. But if you reverse that, then we would do a reciprocal. So that would mean instead of multiplying by 1/4, we would multiply by 4/1, which would mean we would multiply by 4. So if you multiply each one of these numbers by 4, then we would end up with P at 4, 12, Q at 4, 20, and R at 16, 32. Number 10. The following rule represents a dilation. Choose true or false for each rule. The rule is saying that for the x's, we need to multiply them by 2. And for the y's, we need to do nothing, leave them alone. In this rule, the answer would be false. Both numbers need to be multiplied by the same scale factor. On part B, we take a look at the scale factor for x, it's 3/8. We take a look at the scale factor for y, it's 5/8. In this case, the answer would also be false. The scale factor is not the same number. On part C, we take a look at the scale factor for x, it's 4, and for y, it's 4. They are the same. In this case, it would be true. And for D, our scale factor would be -1. And for y, it says leave it alone. Don't do anything. Since we're not doing the same thing for both, the answer would be false. This concludes page 1 of our review. Page 2 of our review, for page 11, ABC was dilated to triangle A prime, B prime, C prime. To find the center of dilation, you're going to need to connect the lines A prime and A, and also B prime and B. And also C prime and C. Use a ruler to do this, and as you can see, the blue line, the green line, and the red line all are meeting at the same point, which is our center of dilation, and that point is 0, 0. To find our scale of dilation, I am going to do the fraction image over pre-image, which in this case I'm going to do A prime B prime over AB. We're going to have to go back and look at the picture in order to take measurements. If you take a look at A prime B prime, then you can see here that it measures 10. A prime B prime equals 10. The next one I need to do is AB. Remember that your graph is going by 2's. AB is 5. So I'm going to use those numbers for my fraction. So 10 over 5. Coming back to our problem, 10 over 5, which that would mean that our scale factor is 2. Number 13. Which of these is the same in both triangle A, B, C, and triangle A prime, B prime, C prime? The vertices are the points on the ends. You can see if you go back and look at the picture that they're not in the same spot. So the answer to this is no. These are not the same. The side lengths. This is a dilation, which means it changed size. So the side lengths are no longer going to be the same. So the answer to this problem is a no. The angle measures, no matter what, always stay the same. So yes, those will be the same. And none of the above, that's not true because we found an answer at C. So C is the answer. These are not correct. Number 14. Look at the graph below. We have a triangle, JLK. And we also have a triangle, MPN. So they're asking us to find out if the triangle is a dilation, if there was a dilation here. So we're going to need to check our sides, which might mean that we might need to do distance formula. So in order to see if our sides are proportional, we're going to have to see the measurements of JK over MN, KL over NP, and JL over NP. Now the only one that requires the distance formula is this one. I can find the other measures just by looking at the picture. So just by looking at the pictures, we have KL measuring 12 and NP measuring 6 and JL measuring 6, and it's going by 2, so 2, 4, and these two complete the third one, which is 6, 2, 4, 6, and the bottom one is just 2. So we might not need to do distance formula because these are not equal. 2 over 6 gives us 2, and 6 over 2 gives us 3, and these are not equal numbers. So we escape from doing the distance formula there. So is it a dilation? Not a dilation. Why? Because the sides are not proportional. So sides are not proportional. We could use our symbol here. Problem number 15. They're asking us to take a look at another graph, and they want us to find out if the triangle ABC is a dilation of triangle DEF. This problem, none of the lines are horizontal or vertical, so we are going to have to use distance formula here. So our pre-image is ABC. Oh, I think I have that incorrect. Give me 1 second. Okay, they're checking to see if ABC is a dilation of triangle DEF, so that means DEF is actually our pre-image, and ABC is our image because that would be the dilation. Okay, so we're now going to do distance formula, and I'm going to set up for that. So I set up my letters A, B, B, C, C, A, D, E, E, F, F, D, with parentheses set up for points, and our square roots, because since we're doing distance formula has square roots. So I'm going to put in my coordinates for A. So A is found at -3, 2. B is found at 3, 1. And C is found at -2, -3. Now I have the coordinates of A, B, and C. But on this next part, I'm going to have to change the signs. So I have B up here already, but I'm going to change the signs to -3 and -1. I'm going to change the signs on C, which will be 2 and 3. And I'm going to change the signs on A, which will be 3 and -2. Now I can add. So I'm going to get -6 and 1, 5 and 4, 1 and -5, and then I'm going to put in their squares. So 36 plus 1, square root of 37. Then 25 plus 4, excuse me, that shouldn't be 4. 25 plus 16 will be the square root of 41. And then 1 plus 25, which is the square root of 26. Now for the green ones. So the green ones are D is found at -6, 4. E is found at 6, 2. And F is found at -4, -6. So now I have my numbers, so I'm going to switch them and switch the signs when I put them down on the bottom. So -6, -2. F will be 4, 6. D will be 6, -4. And now I can add. So when I add, I'm going to end up with -12 and 2, 10 and 8, 2, and -10. 144 plus 4 is the square root of 148. And 100 plus 64 is the square root of 164. And 4 plus 100 is the square root of 104. Now we need to check if all of our fractions are the same. So I'm going to circle the numbers we need in blue. So we need these 3 numbers and the bottom 3 numbers. Remember that the top is our image and the bottom is our pre-image, so they're already set up nicely for us to check. So on your calculator, you can check if the square root of 37 over square root of 148 is equal to the square root of 41 over the square root of 164, which should equal the square root of 26 over the square root of 104. Go ahead and check your calculator and see what you find. Now, it might seem like they look very different from each other, but look at what we find. They all have the same scale factor. So that means this is a dilation. I know it was a lot of work to find out, but it actually is a dilation with the scale factor K of 0.5, or you can write 0.5 as 1/2. That means that ABC is actually half the size of DEF. That concludes page 2. Page 3 of our review. Number 16. We need to set up a proportion which helps us solve this problem. So I'm going to set up x over 8, which will equal to 6 over 12. If I cross multiply, then I'm able to solve. So I'm going to set up a equation. So 12x equals 48. If I divide by 12 on both sides, we find out that x is equal to 4. Number 17. In this triangle, JBW is similar to triangle QKA. Which of the following is true? Well, let's help ourselves out by setting up a chart that would help us. So we have J, B, and W, and those should match with Q, K, and A. So J should be Q, B should be K, and W should be A when we're looking at this here. So is J with Q? Yes. Is W with A? Yes. Is J with K? No. Is J with Q? Yes. Is B with K? Yes. Is B with K? Yes. Is W with A? Yes. So this is a yes. Is B with K? Yes. Is W with Q? No. So we can see that B is our answer. This might be a multiple response problem, so there might be more than one answer sometimes. Okay, number 18. Look at the figure below. Are these triangles similar? Explain why or why not. So I have an angle pair. So we have an angle. We also have a second set of angles that are congruent. So we have another set of angles. And angle-angle similarity is one of the theorems that proves that triangles are similar. So we're going to say, yes, they are similar by angle-angle similarity. End of the problem. Let's go to number 19. Name one additional piece of information that is sufficient to prove that the triangles are similar. So we have sides. but we got to check that they're proportional. So we're going to say 10 to 15, 10 to 15. And we're going to check, because you don't know for sure, so I'm going to put that as a soft check right now. We're going to check if we can do 6 over 9. So 6 over 9. We're going to check if these are equal. If I reduce this, it'll turn into 2 over 3. And if I reduce the second one, it also turns into 2 over 3. So check mark. The sides are proportional. So we have sides proportional. So the similarity theorems are angle, angle, similarity, side, angle, side, similarity, and side, 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 similarity. So we could use side, side, side. So we would say RY over CB would have to equal to 2/3, like we found in our scale factor there. That's one. That's one way we could do this. Another piece of information we could use is our angles. So we could also say angle T. So before I write that down, I'm going to show you. So this would be side, side, side. So that would be one way by side, side, side. Now we're trying to do side, angle, side. So we would say angle T would have to be congruent to angle V. And then that would be a second way that we could do this problem. You could choose one or the other. But this one would be side, angle, side, similarity. And this one's side, 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 similarity. Number 20. Write a similarity statement for these triangles. So if these triangles were similar, then you would say R triangle RTY is similar to triangle CVB. And that concludes page number 3. Problem number 21 did not copy correctly, so I'll have to help you with that in class. Let's move to number 22 through 26. Use the figure where GJ and IJ are angle bisectors of the triangle GHI. So we're looking for the measurement of JGK. So we're looking for JGK, which is actually very easy because they already gave us the other side of this angle, which is JGH, which we already know. And these two are equal since we have an angle bisector. So we know the measurement is 23 degrees. Okay, let's move on to our next part of the problem. So they're asking us to find JIK. Same thing with this one. We know the answer. We know it is 82.1. Simple enough. Last one. They're asking us to find KJI. Now, on this problem here, we have a small triangle which will help us out. It's this triangle here. Okay, that yellow triangle we know has a right angle at K. J is on top and I is on the bottom. We know I is 82.1 and we are missing that angle there. But we know that we have a right angle. So 90 take away 82.1 will be our answer. That means the angle we're looking for measures 7.9. On number 28, they're asking us for the distance from J, which is a point, to GH, which is a side. So we need to go from that point J to GH. So from J to GH is here. Actually, it'll look more like this. And we'll have a right angle there as well. And since we know the other one from the J to JI, we know that one, they're actually the same. So these two measure the same. And we know that measurement, which is 64.3. So pretty easy problem. Our answer is 64.3. Number 29. On number 29, they're asking us for the distance from J to IH now. Same type of problem. They're now asking us from J to IH, which will be the same thing here. It'll look more like a perpendicular. And same thing's happening there. Same measurement, 64.3 also. So those were all angle bisectors. That point in the middle of J was our in-center. And the in-center is the same distance to all the sides. So our answer was 64.3. Number 30. We have a rhombus, EFGH, and we are given that FH, which is a whole diagonal, is 18. So that means if we cut 18 by 2, we're going to know that each one of these is 9. Okay, next part of the problem. GE, which is also a diagonal, is 24. So that means that when the diagonals cross, they bisect each other, cut each other in half. So that would make these two 12. Find the measure of FH. Now, what we want to concentrate on is this little triangle here. Now, we know that we have a right triangle because it is a rhombus. So that means this angle here is a 90-degree angle. I can pull that triangle out so that I could see it a little better. So I've got my right angle there. I know my measures. I turn it the way you see it, so it'll be a little nicer. So my triangle looks like this. And I have a right angle here. And I know this measures 9. And this one measures 12. And I do not know the hypotenuse. So C squared equals A squared plus B squared. Now C is always the side across from the 90-degree angle. So that means I don't know it. X squared equals the other two. A and B are the other two. So 9 squared plus 12 squared. So that would make X squared equal to 81 plus 144. And that would mean X squared is equal to 225. To remove the square, we need to square root both sides. So X squared equals 225. When you remove the X squared, you end up with X equals 15. So that would mean that the measurement of FG, which we just found, X is 15. So we were really looking for this one. So X equals 15. So FG is equal to 15. We found FG. Now, the other interesting fact, because this is a rhombus, is that all the sides are actually congruent. So that means this side measures 15, so does that one, so does this one, and so does that one. So to find the perimeter, you can either do 15 4 times. like that. Or you can do 4 times 15, which will give you 60. And there's our answer. Number 32. Ryan is 6 feet tall at a certain time of day. He casts a shadow that is 12 feet long. At the same time, a tree casts a shadow that is 28 feet long. Find the height of the tree. So we don't know x. Now we're going to set up 2 fractions going this way. Okay, so our first fraction is 6 over 12. And we're going to make that equal to x over 28. Then what we're going to do is we're going to cross multiply. So 12 times x is 12x. And 6 times 28 is 168. And if you divide by 12, that means x is equal to 14. And since everything was in feet, that means our tree is 14 feet tall. It looks like number 33 begins here. The number of calls per, let's move to the next page. The number of calls per day to a fire and rescue service for 3 weeks is given below. Use the data to complete the frequency table. So I started off by putting all my numbers in order. And I decided to go by 5. So 1 through 5 will be here. 6 through 10 will be here. 11 through 15 will be here. And 16 through 20 will be here. So it'll be the number of calls and the frequency of how often something happened. So if I make a table, 1 through 5, I see that I have 1 through 5, 8 numbers here. Okay, for 5 through 10, 6 through 10, then we see 6 through 10, 5 numbers happen there. So 1, 2, 3, 4, 5. So doing tally marks helps. Okay, next 11 through 15. So you can see that I made a table with frequencies happening through our graph, and then I graphed those points on the graph here after I've labeled. So I saw 1 through 5 had 8, 6 through 10 had 5, 11 through 15 had 4, and 16 through 20 had 4. I answered number 35. The ones that had the same frequency were intervals 11 through 15 and 16 through 20. Now they're asking us to estimate the mean and then to compare our answer to the actual mean. So I'm going to estimate my mean somewhere around here. So I'm going to estimate that my mean is like maybe 5.5. Okay, so I'm guessing it's 5.5. Now let's actually do our mean. So that means we have to add up all our numbers and divide by how many numbers we have. So we actually have 21 numbers. Now we're going to add them. So I found out after adding up all my numbers that they total up to 179. And we have 21 numbers. So our mean is 8.52. We weren't that far off, but it's not our mean. So it's best just to add up all your numbers and divide by how many you have. This concludes our review.